Everyone. So we're gonna wait a little bit until everybody is arriving. Okay, let's go. So let me start with this. So my name is Jean-Marc Couffin. I'll be your host today. I'm a trained architect. I've been trained in France and in the US. I'm a senior BIM specialist at BIM One. I've been in that position for the past 3 years. I got into BIM in 2008, and if you look for me, you can find me around Pirate or Dynamo forums usually. Those are some of my interests of the moment. So I work for BIM One. BIM One is the mother company of BIMtrack. We work like sister companies. BIM One helps, BIM One services help develop BIMtrack. We do BIM consulting, and we try to help organization increase productivity through efficiency and technologies. So if you look for us, for every client, we try to develop customized solution, whether it's a project delivery or strategy or implementation or software assistance. We are a multidisciplinary team of consultants, and we try to help in a timely manner. We've had 2,000 plus clients over the past few years in 35 major projects in Canada, and we are about 86 employees right now with 27 on the consulting side. And our clients love us and we love them. So you can see the faces of everybody there. We have developed a few partnerships with trendsetters and best practitioners and also academic institutions here in Quebec and in Canada in general. So today, the topic of today came from the idea behind that we try to make georeferencing understandable and try to lift the curtain on the matter. The series is purpose for all the AEC professionals. So the webinar series itself, over the past few years, there's been an underlying trend around the difficulty to comprehend and manipulate georeferencing and construction projects. In this series, we will try to discuss the principles and techniques to work with georeference projects in different software environments, as well as in different project contexts. So during the first webinar, meaning today, we'll try to establish a common language. So we'll give you the basic introduction of what is georeferencing and discuss these matters. In the second webinar on April 21st, 1 month from now, we'll anchor the knowledge by showing you different concepts and practice in Revit and recap. And finally, on May 19th, with the last one, we'll put this knowledge to practice a bit more and dissect the process of setting up georeferencing in the rules of the art. So as for the webinar for today, we'll discuss the theory behind georeferencing, and we'll try to define what a project referential is. And also we'll address the limitation of BIM and CIM software and their ability to communicate with each other. And finally, we'll talk about the prerequisites of georeferencing for a project. So if you have any question or comments, please indicate them in the conversation window, and we'll try to answer them. So just a regular disclaimer, the subject of today is pretty vast, and the goal is to popularize it, and so we'll try to simplify it, but not oversimplify it. So what is georeferencing? The principle is pretty simple, actually. If you take the definition, georeferencing means establishing a common frame of reference on Earth for all. And if you sum it up, that would be georeferencing is a reference on Earth. Today, we need to think about the project life cycle most of the time when we design a building or trying to construct it. We need to think about all the exchanges that are increasingly shorter, and the stakeholders are much more diverse, and lots of software will sooner or later contribute to the project. So from all these stakeholders, if you take David, Eddie, Maureen, they must be able to communicate on the positioning of the project, and this regardless of the referential chosen, because we are now superimposing our project in 3 dimensions. So if you take all these point of views, they are all quite divergent actually. The project coordinates from the perspective of civil or surveyor, from an architect or a builder, they are perceived in a different way. If you take civil, for example, they usually work with the earth as a reference, whereas architecture usually work with the project with a local reference using Cartesian coordinates and a simplification of the orientation. Usually we take the project north from the orientation on the sheet. The two are on Earth, but they do not share the same point of view. One sees the apple, the other one sees the tree. The main objective of georeferencing is to answer that question. How do you reconcile these two coordinate systems, or how do you make them more fluid in their communication and exchanges? For the record, if you take a look at this small picture, it illustrates pretty well. It's the same building, different files, but for the same building. All the models are georeferenced, and the modeling just started in different places. So if you would use, for example, point clouds, for example, it would be pretty complicated actually to use it. It's always possible to do without georeferencing, but the alternative solution would be to reposition the model every time you exchange the models, or to reinitiate the georeferencing. That would be possible, but the most effective and efficient way is to master georeferencing. So the idea of the common reference, which would be pretty much a definition of it, the Earth or its representation in the reference coordinate system of the area concerned. For example, for Canada, we usually use the Canadian Spatial Reference System, CSRS, with 2 projection, one NAD 83 that would give you the longitude, latitude, and the other one, and the elevation, and the other one, the CGVD, would be the mean level average that you would get from that system. You can find those definitions on the National Resources website of the Canadian government. Here you'll get the link here. So we mentioned that georeferencing is a pretty simple principle, but the application is much more complex actually. The project position is not set in stone, so from sketch to construction, sometimes the building can be moved a few millimeters, the site choice may change, the geodetic location of the project are changing, the land constraints are such that the building cannot be positioned as initially designed, and the building elevation is revised, etc. So we can convince ourselves that nothing will ever change on the project. In fact, that's really true. The punctuality of the operation of georeferencing, the complexity of the tools is also an issue. The positioning of a project is a very one-off event over the life of the project. The tools used have a certain complexity, which is amplified by their sporadic use. A project is rarely georeferenced more than 2 or 3 times during its life cycle. So there are a lot of preconceptions and recipes with no real understanding of what's going on. Some of the risks are to lose the history of the actions on the referential. Also to lose the information and techniques between 2 georeferencing. To sum that up, the scarcity reinforces the critical nature of the transaction, meaning when you move the reference of a project, and the scarcity reinforces the critical nature of the transaction. So one action, meaning Geo-referencing implies 1,000 consequences. There's a real difficulty to anticipate the consequences of geo-referencing a project. BIM and CIM software allows for multiple manipulation, and they speak different language. This language is not homogeneous or even constant over the years. In addition, all the files that make up the project are affected. The domino effect is therefore multiplying on large projects. So some of the risk is, the difficulty is to anticipate the consequences of moving the referential, also to understand the referential of the others. And on big project, you would have big consequences and a possible loss of control. So geo-referencing is always seen as the grain of sand in the gear. There's a lot of people, various skills or knowledge, personalities as well, and various habits. So the general risk is when you manage to get everyone on the same page on every project, it's already a tough task, so it's easy to get the team and the project unbalanced by geo-referencing. Also, it's a very high pressure activity. If you think about the pressure on BIM managers, it's enormous on when the need for geo-referencing arises. And some of the risk implied that the project needs to be on pause and for the back to normal status if and only if the changes are accurate and are properly done, it will be a success. So that would be a lot of pressure on the BIM manager. So now we're going to talk about the two systems, the global one and the local one. I'll explain later a little bit what it is. So for the global system, I'm going to show you a short video that will show you the origin of the Earth, not the start of it, but its center, and its origin. It's the origin of the referential. Its coordinates, it's 0, 0, 0. So if you take the equator and the meridian of Greenwich, those are the two planes making it possible to establish the longitude and latitude and also the axis for X, Y, and Z on the Earth. That would look pretty much like this. And if the thing is, the Earth isn't quite a sphere, and that's where the systems are coming in. The project coordinates are the projection of spherical coordinates on planes defined in the reference system. So the picture shows an exaggeration of the Earth's elevation differences. I think that's a 2,000 or 5,000 times difference exaggeration. So still on the global system, the coordinates of the project in the Earth referential are, in general, the real coordinates on Earth, the shared coordinates for Revit, and they are shared between files and softwares. Now we'll talk about the local system itself. So the local system, if you think about it, the project exists on its site thanks to its location in relation to more concrete elements. Take the trees, a fence, a geodetic markers or a survey marker, and the corner of a wall, etc. All these tangible elements could be the local system of origin, helping us by allowing for simpler coordinates. And we then talk about project coordinates in local systems. This is one of the major issue of BIM and CIM software. They rarely understand big coordinates and must therefore communicate with local ones. As a side note, I wanted to mention that you need to understand that the position of the project in relation to a referential is different from the position of the project in relation to the internal origin of the software. So those are two different things. This needs to be addressed, especially when you deal with IFC or point clouds. Geo-referencing is not always the answer to everything. Sometimes this issue needs to be dealt because you have a different internal origin in the software. Coming back to the local system to illustrate and conclude on the local system, the work in the local system is to establish a reference for the coordinates closest to the reference item. That would be a good definition of it. It would look like this actually. You would set a plan with an origin for the plan, and then you would position this little project accordingly. So the next point of the presentation would be the I'm gonna get it. The interoperability of referentials or coordinate systems. So we will discuss more software related matters actually, but also some geographic ones. If you take such a complex ecosystem of software and it's not even representing all of them, how do you get the softwares to communicate? With such a variety of concept and referential, it's pretty difficult to make them talk to one another. If you take, for example, the civil one, civil would work here in Canada and Quebec in CAN-QM8. It's a projected one. You take maps in WGS84, which would give you longitude, latitude, like the GPS coordinate, and it's not projected. And the CAD one, for example, that would be a UCS, independent from everything. You just specify it at the beginning. The IFC would have different system possible in it. The IFC coordinate reference system, for example, or the IFC site, or the IFC building, etc. Tekla would have the base point, recap its origin, which can be modified, and we'll talk about it a little bit later and in the next webinar when we talk about the point clouds. And finally, Revit as an example as well, but the list is never ending. But Revit has a project-based point and a survey point, meaning two systems of reference. And actually, in that matter, Revit is pretty unique. It uses the two in parallel, and all of this make the software communication a complex matter that requires thoroughness. So communication is a key. As a reminder, it's pretty common to change referential. It's not very difficult. The difficulty comes from the quality of and the documentation of the communication it requires on the matter. So it's all about communication all the way. One of the other issue would be to face the big coordinates, and because big coordinates are usually associated with big problems. This is for two reasons. One reason would be the floating point precision. The way computers store numbers in most BIM software faces challenges due to this single artifact. The other issue would be based on the Earth's geometry. If you take the floating point, this is one of the most common limits in Revit, and not only in Revit actually. The numbers are stored in a way in computers that they are precise up to a certain level, and Revit forbids you to get too far for that reason. So this is a reason for the dancing lines issue. For the dancing line issue, you can have in Revit or in AutoCAD the same issue, and I'll show you that in the next slide. So that's a short example. I drew a project 64 kilometers away from its origin in CAD, and then I inserted it in Revit, and I'm planning on doing things to it within Revit. So I'm gonna try to snap it and zoom in, zoom out, and you can see that the lines are kind of dancing. You cannot recognize the thickness of the wall, and it's pretty hard to snap properly on the corners without knowing what's the problem. So this issue is mostly due to the fact that you have a floating point precision of numbers, and that implies that whenever you're going over that limit, the lines will start dancing. The Earth's geometry is also an issue, and it's mostly an issue on large projects. Very large projects like airports, trade terminal, bridges. If you put them on Earth, obviously, the two ends of such project do not touch the surface of the Earth if the ground was flat. And I'll show you that with a small AutoCAD demo. So you see those nice Montreal projects. So in AutoCAD, I'm gonna draw the Earth, but in kilometers. That's the radius. So 6,371 kilometers. And then from there, I'm gonna position a line tangent to the surface and then go 10 miles one way. So if I go 10 miles one way and then I try to touch the surface of the Earth, you'll see that you get a difference of 20 meters, which is huge actually. So imagine you have a 32 kilometers or 20 miles long project, you would have 20 meters on each end. So that means you need a projection system anyway. So what you need to remember is that basically we're working in spherical projection. An object projected onto a sphere would be stretched. And thanks, Mr. Escher, for that picture. That illustrates it well. So now let me go to the final topic of the presentation. What are the prerequisites for georeferencing a project? This question needs to be addressed before getting into the whole georeferencing technicalities. So some question to ask oneself sometimes. If you're the client or the customer, do you have a recent survey plan? And if so, when is it dated? In what format is it available? And if you talk to civil or the surveyor, in which geodetic system was a survey taken? If it's not written on the plan, please ask for it. Which geodetic marker are used, and do you have a spec sheet for them? From the architect's point of view, is a point cloud going to be required for the project? And at what phase? What type of survey technology would be used? Are geodetic markers from, let's say, the cartographic portal or the survey points from the surveyor clearly identifiable on the map and on the site? There's a few other questions actually that you could ask yourself. Are the scope of the project and the road access included in the plan? Are the level surveys sufficient to represent the complexity of the terrain? Or do you need basically a triangulated topography from Civil 3D, for example? So watch out for the point cloud coordinate system versus the survey plan. A common reference point will be necessary and needed. And that's a critical question for their use, because the insertion of the point cloud with respect to the internal origin in the software like Revit, for example, you would have to take care of that from the very beginning if you don't want to mess up your project. We'll come to this in the future webinar, in the second webinar, where we will explain how to use the local origin to make a point cloud work in Revit, whatever the possibilities you have. So the next point would be to talk about how would you communicate your requirements to the surveyor. So CAD files have versions, so you need to be aware of that. And I guess you know, but you have to take care also about the units. Units needs to be checked. Usually they use meters, but it's always good to ask beforehand. Is the project geo-reference and with a single or multiple UCS? If you have multiple UCS, beware that when you insert that in Revit, you would have to pick one properly. It's usually a better practice to maybe remove the unused UCS, the one you don't need. Is there a marker that can be identified and physically identifiable on the site and that will not be demolished or moved? Ideally, it needs to be close but outside of the work area so that these references last throughout the construction. No object or object origin outside of the site and project work area. Right now, when I'm talking about that, I'm thinking very hard about the CAD files. Usually when you have the origin of a CAD file that is somewhere very, very far away and something is drawn next to it, usually that's where you get the dancing line issue. So that's another point that we'll talk about in the next webinar, where we'll show you how to deal with it. After that, do you have a reasonable file size? Usually purge shouldn't be more than 5 megabytes, an AutoCAD file, or maybe 2 megabytes would be ideal. But it depends on the amount of information that it's contained and the ones that you required as well. Do the surveyor will provide you with geodetic marker sheets, data sheets. That's the next point actually, and that will pretty much conclude the presentation. Where would you find these geodetic marker data sheets? Actually, there's a pretty good website for Canadian mostly, and that's the Portail Cartographique, where you can find these data sheets. I'm going to show you where and how exactly. So once you go on the website, you'll be on the map of Quebec here. You can set the layer to the geodetic network, and then you can zoom in or type in the address. And for the example, we'll go to the Montreal airport. So once you're there, you can identify with the information, you can get the information of the marker, and from there you can download the data sheet. And the data sheet looks like this. It's coming up. And from there you have the ID of the marker, and you can find the longitude, latitude, as well as the elevation of the project. So that concludes it for today's webinar. In the next one, we'll be a little bit more hands-on, and we'll talk about Revit, Recap, point clouds, and master file. So we'll discuss the Revit coordinates as well as the origin of point clouds, and how to coordinate coordinates with a master file. So if you have any questions or comments, we'll answer to the questions in the Zoom chat, and as well as the one that you can send to info@bim1.com. And I thank you for being here. Thank you. Bye-bye.